Hello, this is demo 4 of the zells prototype number 8. Since the last demo, I once again refined the computing model a bit, so this demo mostly shows the new model. This means that almost all graphics you see here are merely to visualize the model and do not represent a user interface. The computing model is inspired by the original model of Smalltalk, with objects, or actors, running in their own processes. I call this basic building block a node, and the only thing a node can do is receive bit streams that I call a signal. So let's create a node. And make it receive a string. Not much happened. To make something happen, I can use a node that prints everything it receives to the transcript called a transcript node. Now when it receives a signal, it prints it to the transcript. Let's visualize this node. So I can let a node receive signals directly. But different from Smalltalk objects, nodes aren't stored under a name in memory, but live on something called a mesh, which is a network of connected nodes. Let's build a mesh consisting of the transcriptor node and another node acting as a sender. Since the sender is a mesh node, it is able to connect to other nodes using channels. Let's open a channel with the transcript node as its receiver. So now every signal that the sender sends, the transcript node receives. But as you can see, when I send hello, what is actually sent is a structure consisting of an ID and a message. The reason for this is that signals are actually broadcasted through a mesh, so I use an ID to avoid receiving the same signal twice. Let's close this channel and extend our mesh a bit to illustrate this. So if I build a mesh like this with the sender connected to both of these nodes and both of them connected to the transcript node, every signal the sender sends is now received twice by the transcript node. But mesh nodes know about this and deduplicate signals based on their IDs. So if I put another node in front of the transcript node, and connect them like this, it will receive the signal once again. Channels only transmit signals in one direction. So if I connect the sender to this node like this, the wrong way around, then whatever the sender sends won't be transmitted. But it is possible to create channels in both directions. Now what if I want to send a message to only a single node in a mesh? Since signals are broadcasted to every node, I need to add a little bit more information to my messages in that case. Let's say I want to talk to an echo node and receive its replies. To know who to send a message to, the echo node needs an address. And so the echo node knows who to reply to, the sender also needs a message, an address. Now if I connect echo to the mesh in both directions, the sender can send a message with a content to echo and receive the reply. Both messages are also received by the transcript node and therefore are printed to the transcript as well. If I send a message to any other receiver, echo will ignore it and not reply. Now if I want to do something with that reply, I can make echo send it to a different node by changing the from address of the message. Now echo will send its reply to this address. All I need now is a node which I can tell how to react to the received message. That is a dynamic node. Which needs to have the address that I specified as the sender of the message. And I just connect it to the sender like this. Now let's tell this node that its reaction to a message will be to print the message simply to the transcript. And let's make it uppercase. Now if we send this to echo, the reply is received by our new node over here and printed to the transcript in uppercase. Since sending a message and processing the reply is a common operation, a mesh node provides a method for just that. So we don't need this node here over anymore. Instead, I can tell the sender what to do with the reply. In this case, we do the same, and let's make it reverse again as well. Now if I send this, it will create a temporary node, in this case called sender/reply7613, with the sole purpose of receiving and reacting to the reply. So it's immediately deleted once it has fulfilled that promise. So far, none of the nodes I've used had any state. So let's look how to deal with a stateful node. For example, one that contains a text value. I can change the value of the text node, currently it's empty, by sending it a message with a new value and making sure it can receive it. So I use the sender to send a message with the content set to foo to text, which will make text change its content. There's also a UI element which lets me do this, called the text portal. Portals are nodes as well, so they can be connected to other nodes with channels. It's a job of a portal to translate a user intent into messages. So if I want to change the text value, first I need to point the portal at the address of the node that I want to change. And then I can use it to set the text. I can also do this with the graphical input over here. The last thing I would like to show you is how to build a message like this one, but with nodes. A message is a structure and contains things, which can be created with a container node. So let's create a container representing the message we want to send. We give it the address message. The message has one text element with the name to and another container with the name content that has again a text element with the name set. So let's create these elements. I can clone this container and call it content, and I can clone this text, name it to, and again name it set. Now that I have all the parts for the message, I need to make sure they can talk to each other. So I clone this node and connect them all to it. Now that they are connected, I can change the text value with the text portal. So I want to send it to text, and I want to set it to hello. That's it. Note that so far I don't have actually created the structure of the message. I only created the parts of it and connected them so they can talk to each other. To build the structure, I can use a container portal. I connect the portal to my little mesh over here and point it at message. So now I can add content and to this container. As you can see, the addresses of both nodes changed as they are added to the container, because containers are namespaces. So if I change the name of the container, the names of its inhabitants change as well. But let's keep it short. And to complete the message, I need to put set into content. So I point it at content and add set to it. Now that the message has its correct structure, I can send it using a sender portal. All I need to do is connect it to the mesh that contains the message and connect it to the mesh that contains the receiver, in this case our text down here. And then I can send the message by giving it the address of the message I want to send. This causes quite a commotion, but in the end the text value is changed. If we look at the transcript, we see that first a message is sent to the message node, asking it to turn itself into a message, and this is then sent to both inhabitants of the container as well, and so on. In the end, the message to be sent is sent as a content to the sender portal, which then forwards it as a message to every mesh it is connected to. That's all for today. Thank you very much for watching, and stay tuned for more.